Welcome back to the deep dive. If you are preparing for a meeting, trying to catch up on this crazy field, or just insanely curious about how frontier AI is going to affect knowledge work, your work, the challenge, how do we measure AI's real impact on the economy before massive job changes actually happen? The metrics we usually rely on, like adoption rates or even GDP reports, are what the researchers call lagging indicators.
Right, they only tell you what's already happened.
Exactly. They tell you about last quarter.
And waiting for that standard economic data to tell us what AI is truly capable of is, well, it's just a slow reactive approach. Major technological shifts, whether you're talking electricity or the internet, often take years, sometimes decades, to really show up in those broad statistics.
So to get ahead of the curve, you need a leading indicator.
You need a leading indicator, a direct, rigorous, and immediate measurement of current model competence against high-value professional human work.
And that is our mission today. We are diving into a groundbreaking new evaluation benchmark called GDPVal. We are going to unpack how this benchmark was constructed using highly experienced industry experts, and most importantly, we will reveal what the very latest, most advanced frontier models, the true heavyweights like GPT-5 and Claude Opus 4.1, actually achieved.
And these aren't toy problems. They were asked to complete complex, real-world professional tasks.
I'm really excited for this one.
The scope here is it's unprecedented. GDPVal evaluates tasks across the top 9 economic sectors contributing to the U.S. GDP, covering 44 distinct, high-earning occupations.
So it's not about passing a theoretical test.
Not at all. It's about generating a final professional deliverable that is deemed economically valuable by an industry expert. It's probably the most rigorous real-world measurement of AI competency we've seen to date.
Okay, let's start with the sheer scale and the realism factor, because that's what truly sets GDPVal apart from traditional academic evaluations.
Right.
The benchmark focuses on a gold subset of 220 open-source tasks, but the full set covers over 1,000. These 44 occupations, spanning everything from finance to engineering, collectively earn about $3 trillion annually.
$3 trillion! It's a staggering number. And the key realization by the researchers was that if you want to test economic value, you have to test actual work product.
Not just a question and an answer.
No, absolutely not. The tasks weren't just created in a lab. They were sourced directly from the highest-earning digital knowledge work occupations within those 9 major sectors.
And the quality of the people creating these tasks mattered hugely.
Yeah.
We're talking about experts with, an average of 14 years of professional experience?
Yeah, 14 years. They had to pass really rigorous screening because they were asked to create tasks that mirrored their most complex, high-value assignments.
Which ensures the benchmark truly reflects the difficulty of real-world knowledge work.
It's crucial because that experience ensures the tasks reflect all the nuances and subjective challenges professionals face, not just the textbook answers.
And the complexity here wasn't just technical difficulty, it was also about duration.
Oh, absolutely. The tasks on average require 7 hours of focused work for an expert professional to complete.
7 hours? That's a full workday for one deliverable.
It is, and some even stretched into what they termed long horizon difficulty, so tasks that would span multiple weeks of effort.
Why is that long horizon stuff so much harder for the current models?
It really gets at memory, planning, and state management. When a task takes 7 hours for a person, it usually involves multiple steps, synthesizing different results, remembering constraints across different sessions.
Right, I have to pick up where I left off yesterday.
Exactly. And models can struggle with maintaining that coherence and focus over many steps, especially when they're generating complex, multimodal deliverables. They have to keep track of multiple file types at once.
And that multi-embodity is another layer of realism here. These aren't just text prompts. The models had to manipulate various real-world files, spreadsheets, slide decks, CAD designs.
Sometimes even audio and video, and they might have to parse up to 38 different reference files just to get the necessary context for the job.
Wow, that's like trying to do your job with a very, very full inbox.
That's the idea. It mirrors that information overload that a real professional faces every single day.
Let's make this tangible for the listener. Give us a few examples.
Sure. So a manufacturing engineer might be asked to design a 3D model of a cable reel stand. It's precision work that has to meet very specific requirements.
Okay. What about, say, a financial analyst?
For them, it might be creating a detailed competitor landscape analysis for last-mile delivery services. That requires serious market parsing and strategic thinking based on dozens of proprietary data points.
And I love that they included service roles, too.
Yeah.
It's a concierge task, creating a week-long luxury Bahamas itinerary for a family of 4.
Right, that tests not just data retrieval, but style, aesthetic judgment, organization. You're balancing a budget with what a client actually wants.
And then on the really serious side, a registered nurse had to assess skin lesion images and generate a full consultation report.
The breadth and, frankly, the clinical stakes of these deliverables are just staggering.
Okay, so creating the test is only half the battle. If the deliverables are that complex, how in the world do you grade them objectively?
That's the next critical question, right?
Once they created this rigorous benchmark, how did they ensure the grading was just as robust?
Well, the quality control pipeline was intense. Every single task in the full set went through automated checks and an average of 5 human expert reviews.
5 different experts looked at each task.
5. And they rated them not just on technical correctness, but on how representative it was of their real job and its quality against the ultimate standard. What would a top client or your boss expect?
And the primary evaluation metric they settled on was this blind, pairwise expert comparison. How exactly did that work?
The process is elegant in its simplicity, really. An expert in the relevant field was given 2 unlabeled work deliverables, output A and output B.
They don't know which is which.
Exactly. One might be the model, one might be the human expert baseline. They have no idea. They just rank them. They decide which one is better.
And they're weighing both the objective stuff, like did the math check out?
Right, were all the instructions followed, and also the subjective factors, like the overall structure, the persuasive style, the format, the aesthetics of the final deliverable.
That level of blinding is so essential. It ensures the expert is judging the work, not the reputation of who made it.
Absolutely. And this rigorous method was time-consuming. Grading each comparison for that gold subset took over an hour on average.
An hour per comparison. Wow.
It just underscores the high commitment required to validate this against real professional standards.
The researchers even tried to build an experimental automated grader, right, based on a high-end GPT-5 model to see if they could automate this.
They did. And that automated grader achieved 66% agreement with the human expert graders.
Okay, 66% sounds decent, but it raises a profound question. How good are humans at agreeing on professional quality in the first place?
And that's where the numbers get really interesting. The human expert inter-rater agreement, so how often 2 professionals in the same field agreed on which deliverable was better, was only 71%.
Only 71%.
It highlights the inherent subjectivity in high-value knowledge work. The fact that the gap between the automated grader and human consensus is only 5 percentage points shows just how much nuance and personal preference dictates what constitutes a high-quality professional deliverable.
It kind of confirms that even humans aren't perfect judges of their own work quality.
Exactly.
All right, let's move from methodology to the outcomes. They benchmarked the current frontier heavyweights. GPT-4o, Grok 4, Gemini 2.5 Pro, and then the top-end models like GPT-5 and Claude Opus 4.1. Who claimed the crown?
Well, the headline finding on the gold subset is pretty clear. Claude Opus 4.1 was the best performing model.
And what was a quantifiable score? How often was the model actually preferred over the industry expert?
In those blind pairwise comparisons, Claude Opus 4.1's deliverables were rated either better than or tied with the human expert deliverable in 47.6% of tasks.
Almost half the time.
Almost half the time. You are looking at models that are effectively achieving near parity with a human industry expert on nearly half of these incredibly complex, high-value tasks.
That is a critical finding. It confirms the thesis that these AI capabilities are not years away. They are fully competent right now. If we zoom out and look at performance over time, what trend did they find?
Looking specifically at the evolution of frontier OpenAI models on the GDPVal gold subset, the data shows performance has been improving roughly linearly over time.
A straight line going up.
Pretty much. And this is significant because it suggests a predictable, continuous, and steady march toward greater competence, rather than sudden, unpredictable leaps.
Now, in the real world, models often have specializations. Did they find models had different strengths depending on the output? Text, a spreadsheet, a slide deck?
Yes, there were clear distinctions. Claude Opus 4.1 generally achieved the best results across most output types. It really excelled in the subjective areas like aesthetics, slide layout for PPTX, and overall document formatting.
So it makes prettier documents.
It makes the most visually professional-looking work, and it performs really well on PDFs, XLSX, and PPTX outputs.
And what about GPT-5?
GPT-5 high-led for pure text outputs and was specifically noted for its superior accuracy. So, following detailed, nested instructions and performing correct calculations consistently.
So you might have a trade-off. Claude for visual polish, GPT-5 for the technical rigor.
That's a good way to put it. But both are performing at an incredibly high level against human experts.
Let's revisit that finding about long horizon difficulty, because this is probably the most relatable data point for our listener who handles projects that might span days or weeks.
Right.
Does model performance hold up as the tasks get longer?
This is a critical insight from GDPVal. The model win rates are highest for the shortest tasks, those requiring 0 to 2 hours of expert completion time. For the strongest model in that category, the WINTI rate was 56%.
So better than a coin flip for short tasks.
Exactly. For quick, contained knowledge work, AI is often the preferred choice.
But once the task duration stretches out,
Performance declined steadily as the task length increased, dropping all the way down to only 37% for tasks requiring 8 or more hours of work.
that confirms the intuition that models currently struggle most with long-term project management, sequencing, and maintaining context across multi-day projects.
That's right.
Okay, that 47.6% success rate means the human expert was still preferred over half the time. If we want to move toward full augmentation, we need to know the failure modes.
We need to know why they failed.
Exactly. What were the primary reasons the models lost the comparison?
Across the board, the single most common reason models lost was instruction following failures.
So they just didn't do what they were told.
Pretty much. Despite their advanced reasoning, the models frequently failed to fully adhere to the prompt, missed constraints, or ignored critical reference data that the professional provided.
That's a fascinating vulnerability. It's not necessarily a lack of intelligence, but a failure in attention or adherence to detail. Were some models better at this than others?
Oh, significantly. Claude Opus 4.1 had the fewest instruction following failures at only 14% of its total losses.
Okay.
Conversely, models like Gemini 2.5 Pro and Grok 4 most often lost due to this 40% and 35% respectively. They'd frequently ignore the reference data or just promise a deliverable and then not provide it.
In GPT-5's primary struggle.
GPT-5 High actually had the fewest accuracy errors, so its calculations and core logic were really sound. Its main failure mode was formatting errors. About 10% of its losses came from visual or structural issues.
Which speaks back to Claude's superior aesthetics.
Exactly.
We have to spend time on the severity of these errors, because a formatting issue is inconvenient, but a catastrophic failure is dangerous.
It's a different world of risk.
What did the expert review find in terms of real-world harm?
When experts analyzed GPT-5's failures, the most common category, about 48%, was acceptable but subpar, usable but weaker than the human baseline. However, approximately 3% of failures were rated as catastrophic.
3%.
Yeah.
So if you integrate a frontier model into a high-stakes workflow and run 100 tasks, 3 of those completions could potentially be harmful or dangerously wrong.
That's a massive risk exposure. It is the ultimate risk factor. Catastrophic means the output would result in real-world harm, giving a wrong diagnosis as a nurse, recommending fraudulent activity to a client, or generating deeply insulting communications.
It just reinforces why human oversight is not just desirable, but absolutely non-negotiable for high-stakes professional work right now.
Absolutely.
So, we know the failure modes. Can we fix them easily? What did the researchers find when testing immediate improvement levers?
They identified 2 simple levers. First, reasoning effort. Simply running models at high reasoning effort versus low predictably improved performance. The model just needs permission to allocate more compute to the task.
Okay, so just turn up the dial.
Basically. And the most striking immediate result came from simple prompt tuning, or what they call scaffolding.
Scaffolding, what do you mean by that?
They crafted a customized prompt specifically for GPT-5 that encouraged rigorous self-correction. It told it to, rigorously check for correctness, avoid special characters, and convert visual deliverables to PNGs for self-inspection before submitting the final file.
It's like giving it a pre-flight checklist.
That's a perfect analogy. And the measurable payoff for that simple scaffolding was a significant 5 percentage point improvement in the human preference win rate.
5 points. just from a better prompt.
Yeah, it moved GPT-5 from 38.8% to 43.1% in human preference. It helped eliminate issues like black square artifacts in over half of the generated PDFs simply by forcing the model to inspect its own work visually before calling the task complete.
An immediate, measurable gain achieved without retraining the core model.
It's a huge deal.
Let's focus on the economic payoff. If a model can get this close to expert quality, what does that mean for the clock and the balance sheet?
The researchers analyzed a specific, highly realistic hybrid workflow scenario. This assumes a human expert reviews the model output and only steps in to fix, edit, or complete the task themselves if the output is unsatisfactory.
So the try using the model, fix yourself approach.
Exactly, which is what many professionals are moving toward. The human expert shifts from starting from scratch to being an editor and a quality control specialist.
And what were the predicted efficiency gains for the strongest model in that scenario?
In this hybrid scenario, GPT-5 High showed a speed improvement ratio of 1.39 times faster than an unaided human expert, and a cost improvement ratio of 1.63 times cheaper.
That finding is profound. It suggests that AI isn't about wholesale job replacement. It's augmentation that fundamentally shifts the expert's role from high-cost creation to high-leverage editing and quality control. That potential for systemic efficiency is huge. But we know performance varied widely across fields.
It did, significantly. Models approached parity on tasks in sectors like government, retail trade, and wholesale trade. They achieved really high success rates there.
But they still struggled more
In the highly specialized fields, professional, scientific, and technical services, the sectors that rely most heavily on unique context, deep tacit knowledge, and managing highly ambiguous requests.
That brings us back to context. In professional life, half the job is figuring out what the client actually wants.
That was validated by their under-contextualized GDPVal experiment, when they deliberately made the prompt shorter, omitting critical information like where to find the data or what the expectations were.
Model performance tanked.
It degraded immediately. This shows that the true high-value component of expert work isn't just the execution, but the ability to navigate that initial ambiguity and figure out the full context of a task.
Models still rely heavily on the human expert to provide that full, rich context.
Precisely. The moment you remove that scaffolding and force the model to infer context, the performance drops.
Finally, for the benefit of our learner, we need to acknowledge the critical limitations of the GDPVal benchmark in its current form.
Absolutely. The current version focuses only on self-contained knowledge work and digital deliverables. It excludes manual labor, tasks requiring extensive tacit knowledge, that deep experiential understanding you only get through years on the job.
And the big one, collaboration.
Right. It excludes tasks requiring communication or collaboration between individuals. Professional life is fundamentally collaborative, and that crucial interpersonal element is something future benchmarks will need to incorporate.
So what's the final takeaway? GDPVal is a powerful, real-world measure that shows frontier AI is rapidly approaching the quality bar of a human industry expert. We saw that 47.6% winning rate. But humans are still essential for oversight, quality assurance, and handling that critical 3% of catastrophic mistakes.
And importantly, the researchers open-sourced that gold subset of 220 tasks, along with the experimental automated grader, to facilitate further research. That kind of transparency is essential for tracking progress reliably.
We saw that performance declines steadily as task duration increases, from a 56% WINTI on short tasks down to 37% on 8+ hour tasks. But that prompt tuning experiment proved that simple, targeted improvements in scaffolding can yield immediate, measurable gains.
Right.
This raises an important question. As AI agents become systematically trained through better prompts and internal checks to review their own work for specific failure modes, like we saw with formatting, will the decline in performance from multi-day, long-horizon tasks be eliminated simply by forcing the model to slow down and check its work at every step of a complex project?
I mean, if self-correction works for a PDF artifact, why wouldn't it work for a missing instruction?
It's a great question.
That notion fundamentally shifts the bottleneck from raw capability to systematic execution, which might be a much easier problem to solve.
Food for thought indeed. That's a wrap on the deep dive. We'll see you next time.